function static variables. So let me Visual Studio and let me bring up the stack. Okay, so when we are granted memory for our program, we have stack memory, heap memory, data memory, code memory, global variable memory, and finally static variable memory. And I know we focus in detail on the stack and heap, but we'll cover static memory just this one time, right? To more or less understand how does a variable keep its memory, right? So when you create a static variable, it's created in this memory space, and the stack references the memory space, and it can increment the value of that variable. And even though that variable is created in the function and the function executes, exits, is removed from memory, the static variable is always in memory. So that's how it is able to keep its value throughout the lifetime of the program. Let me see here. Close folder. Close all. And I will, it looks like I need to check this code in. So let me see. Okay, so I'll check those in. And now we can go and create some examples. We will create a void function, and then we'll just name it something like use static variable, and that's the signature. And we copy this to the implementation file or the CPP, and we will create a static variable. Let's see, auto num and let me see if I have IOStream here. Nope. Okay, let me include IOStream up here, that way I can use cout in my function right here. So cout the value of static, and we'll create a new line. After we display it, we want to increment the value. Okay. We go into main, so this is void, right? So we're not going to be able to test it, and that's fine. We use static variable. Make sure nothing else is executing in our program, and maybe we call it a few times, 5 times. We come to CMake to run this example, 04, and we run it. And at 0, let me see what happened here. Oh, it didn't do anything because, well, this statement doesn't do anything. We need to tell it to do something, right? So static, increment it, and we try it again. Okay, so 0, 1, 2, 3, 4. So notice from our lectures on function local variable scope, we know that any variable that's created in this block lives while the function executes, unless it's a static variable, right? So we can say, okay, so let me do this, and then I will write them next to each other, and I'll say num here, and I'll also try to increment num, so that we can show that this one will always be 0, but this one will keep its value for each function call, and it'll keep on incrementing. So we go ahead and so notice 0, 1, 2, 3, 4, and num is all zeros because this is not a static variable. So this variable right here is created when the function loads onto the stack. We output its value, and then we try to it increments, but we don't get to see that. I'm sure if we do see out over here, then we'll just see ones. Each time we'll see one. But point taken, right? It'll always be created and removed as soon as the function completes executing. And the static variable, since it's created in a different region of memory, it lives through all the function calls. Okay. Questions on this topic? Yes, so yeah, so it's different from a constant because a constant is read-only and a static variable is read-write. Notice here we are adding 1 to its current value. And a static variable will live as long as our program lives. So if we come back and look at this memory that's granted to our program, we have the stack. This is where functions are called. So our functions called and loaded onto the stack. Loaded onto the stack here. Auto num is created each time the function is called. And we increment it. It's 1, but we're not displaying after we increment it, right? But as soon as the function exits, num is removed from memory just as the function's removed from memory. The static auto num static, since it's created in a different region of memory, static memory, as soon as our program runs, like that value is created for us, right? So the function can call it and increment it and finish executing, but this static variable will never be reset or removed from memory unless our program is stopped, right? So that's why we are able to increment, right? And if we look at the output, on the right side we see num, so it's 0, and on the left side we see num static through each function call. And let's look at what we did. We called use static variable 5 times, and 5 times num was 0, and as you can see here, num static kept its value persisted for the life of our program. So that's yep. Yeah, and depending on where you land a programming job, some are okay with static variables, some shops are not, and it depends, right? So use cases for this one, maybe like a bank that wants to keep its balance for all its national balance, and then if data is accessed from the regional bank, then the regional balance will show, but then the national balance for that bank will show, right? Like that's some example. So it'll persist the value for all the local banks for the headquarters, or all the regional balances combined together. Okay, come back here, and then function overloading. So function overloading is a function that has the same value type. Calculate weekly pay, the same function name, but different number of parameters. And we can have another one like for hourly employees, we might say like hours, and I'll use integers just to make this simple for the test case. Hours and rate. So this is an example of a function overload. The function has the same return value, integer, same name, calculate weekly pay, different number of parameters. And this is perfectly okay. In most programming languages, you should be able to do this, okay? And we can go ahead and type that example. So before I go on, questions here? Okay, so no questions. We go to our header file and we will create that calculate weekly pay for a salaried employee. Okay, so here we return salary divided by 52. And then we can go into our test case to test this function, and we'll do the same thing for the next one. So let me see here, we're examples for test case okay, and we require okay, that one's already there, so calculate tab, and we can use maybe what, 52,000, right? Make it a nice easy number to solve. So that should give us the value of 1,000, and we can execute this test case. And functions are good, but they do have their cons, right? So we'll start covering classes in the next lecture. So we'll see why the move was made to object-oriented paradigm for programming. Okay, how do we designate which one we want to execute, right, on an overloaded function if they have the same name? So we'll go there, right? But just from looking at this example, this one has one parameter, and then going back to this second example, so if it has one parameter, it'll execute this one. If it has two integer parameters, it'll execute the second one. Okay, so that one's good, and we're not worried about adding more assertions. We'll go back here and we'll create the next overload. So calculate weekly pay int hours, int rate. Whoa, what happened? Okay. And we go to the implementation source code. We make this one easy also. We just say, oh, okay, so I want to return hours times rate. And then we go back and create another test case. Test case, test calculate weekly pay for hourly, I can't type, hourly employees. And here we say, okay, I want to require and calculate weekly pay for somebody who works 40 hours and makes $10 an hour, and that should equal to 400. Let me go back here. Control space, okay. Usually that works. I don't know how to bring up the parameters, but if we do this, notice we get this context dialog, and it's saying we can use one integer, and if we click down right here, now it's saying you can also use this function with two parameters, with two integer types. So it's giving us some hints. Control Z. And then we can go ahead and run this test case. And there'll be a lot of situations where you have to overload functions depending on the, like here it depends on how someone's paid, and that's how, but you can still calculate weekly pay even for salaried employees and for hourly employees, and maybe others, maybe they get bonuses, I don't know, right? A lot of different use cases for this. So when this executes, the compiler comes here and it's like, oh, okay, so this is the one I'm looking for. And if this one executes, then it finds the function with two parameters and it's like, oh, okay, so this is the one I'm executing. And notice green is good, up arrow space dash S, enter, and our overloads work, and notice we don't get any warnings or anything. The compiler completely understands what we're trying to do. And this is a concept of function overloads. Questions? The most awkward seconds in class, right? Like after I prompt for questions. Okay, so no questions here, meaning we can move on, and that ends the chapter on functions. I think in the book they were talking about using functions to run programs. That concept is known as like drivers, but we've really been doing that already, like since the beginning. Like this is a driver for a test case, and then in main, like we're calling our functions, right? So that's why I didn't cover that topic. It was mainly like we've been doing that already, like for what, 2 months. So it's function overloading. Look, that seems like it could get really confusing fast. Actually, it's used a lot because there's always situations where you need to give the users, in this case programmers are users of functions, right? So other programmers will decide how they want to use the function. I mean, if we give them 3 or 4 options, they're like, oh, okay, so I can send in this parameters. So it's very common. in the industry. This concept also is supported in class methods or class functions, so it's actually very popular. Because I mean, if you think about it, then you don't. I mean, these functions are related. This one's easy because they're dealing with payroll, but maybe even like a graphics program would, like, if you send in certain parameters, maybe for width and height, and then maybe others like width, height, and depth. I don't know, right? So they're very popular, and it might get confusing, but once you're experienced, then you see this and it's kind of like, oh, okay, I know what they're doing. Okay. So strings. So let's go back to how C++ is constructed. So C++ has the core language, and there we have keywords like simple data types like integer, double, the keyword void for functions, keywords like the while, for, switch, and etc. The standard library, you can look at the standard library like little snippets of programs you can use. Like the string, it's a program somebody wrote for us. It's written in a class, meaning it has variables inside and functions we can use to represent a string. And a string is a sequence of characters. And it could be something like that, right? It's a sequence of characters. So they created a string class to represent that. To use a string, we have to include the keyword string, so include string. And let me show you the code. I think it was in while where we used this string. Yeah, so you have to include string, and that's the first step. Second, you have to help the compiler with the namespace. Yeah, in other words, where, in the string header do I find string, and we use stud string, and then the compiler's like, okay, I know what string is. In main, we can say using string. This works again because we've included string in the header file, okay? And then we can say string name. And once we do that, C++ understands that it's a string. If we don't tell it what a string is, then it doesn't know where to find the string, even though, let me look at value ref. Actually, let me see, main value ref. I didn't use the right one, but let me go ahead and use this one since I'm here already. Well, actually, no, not this one. I don't want to remember to write that code. It was in while, right? So while.h, sorry. So while.h, and we'll go to main here, and then let's forget about this one for now. So while main.cpp, while.h has string, okay? And we want to use string here. We can say, okay, I know strings included in while.h, so I can just say using string, and then I can say string name. That creates an empty string in memory. If I remove that, then it's kind of like, I don't know what string is. So we know that we can also do this to help the compiler, and now it magically knows what it is, right? We help it with the namespace. However, the recommended way, the industry recommends, not me, okay, is like this, and the CPPs. And now we have string, okay? But I'm pretty sure if you've been paying attention, you already know this, right? That if to use strings, you need the include and you need to help it narrow down the namespace, right? So, and that was the admin work to use a string. But how is a string in memory? Like what goes on behind the scenes? So are we going to talk about vectors in functions eventually, right? So we're strings, right? So let's take care of strings first. Was there a question in the exam about vectors? There's one. I meant to remove it. Is it the prime question or which one is it? I thought I had removed it. The cookies? Okay. I'm not going to talk about it today, but what I will do is I will put an example on the main page of the midterm exam discussion board. How to create a vector, how to add items to the vector, and how to return a vector to the function. I thought I had removed all the vector questions. Yeah. Usually by the time the midterm exam comes around, I've already covered strings and vectors. So there are string questions, but I noticed that the questions on strings aren't really that difficult, and I put snippets of this is how you create a string, this is how you add characters to the string. But if you have questions, by all means, please send them to me. Yeah, so I'll do that. Sorry about that. I thought I had removed it. Okay, where was I? Okay, so how is a string in memory? So that's our next topic. I mean, how is that guy? How does it look in memory? String overview, characters and strings. So characters and strings in memory. Yeah. Remember, reference means just use the ampersand. So, okay, I'll put an example. Okay, so if we have main and we have a character and we have stack memory here and heap memory, we're not gonna diagram the whole activation record. We just want to focus on how these records would be on the stack, right? So just to mimic the activation record, this would be the scope for main. So meaning this block of memory is granted to main. And when this statement executes, maybe this is buffer, and then the letter A would be here. And maybe this is like 199. And we have on the right side heap memory. A character, the way I've created it, is not stored on the heap, okay? And what if we, assuming we have the proper include and the using statements in this example, if we say string name double quote Joe. Okay, so this 99. Let's go with 96 here, and then this one 95. Okay, so how or where is Joe in memory? And this is where a string differs from Joe. Before I map it on memory, C++ implementers of this compiler, GCC, they had to write code for the string class. And they use an array of characters. So they create memory dynamically behind in the class. They wrote some code to create memory dynamically, and that memory, if it's created dynamically, is stored on the heap. The rule in C++, if you create memory dynamically, you are responsible for removing it when it's no longer needed. Luckily, the string developers have taken care of that for us. So even though behind the scenes, Joe is on the heap, they have written expert code to make sure that the memory is created and we use it, and then as soon as the memory is not needed anymore, when is that? In this case, it's easy, when the program starts exiting main. But if this was another function, maybe like uString, say this was uString, the string name would be removed from memory when uString would be finished executing. Okay, so it's important to understand that. But they have written that code for us. We don't have to worry about it. And I'm sure that's how Python string implementers did it too for you all. So assuming they put the algorithm gave us these 3 spaces for Joe, and then this would be y 100, 96, 92, 88, 87, 86, 85. Why 1 byte here? Because a letter is represented in 8 bits. Okay, it's anything from 0 to 255, so that's 8 bits. What goes over here? Anyone? Just by looking at the diagram, that you should more or less be like, oh, how does it know where J is? And then if you ask yourself that question, then I'm sure you can make an educated guess on what goes on the left side. The reference to heap, which reference? That's close. Yeah, the address on the heap, right? So Y87 would go here, obviously in a 4-byte number, right? And that's how it knows how to find its character array that was created dynamically on the heap. And we don't have to worry about that. When we use string name equals Joe, all that's happening behind the scenes. We don't even have to think about that. Okay, questions here? Yeah, no, not the index. It would be the address. But I guess if we really think about it, an index is an address, but we don't see that. Because if you recall from the activation records, so I don't want to dismiss that comment, right? So let me go function activation record, right? So if we think about it, I told you that activation records have their own memory space. So then we can jump back over here. So then this is its own memory space. So we can say name of 0 is J, right? So I'm sure that's why the comment was, well, the index. Well, behind the scenes, there's a pointer to this address, and it's like, okay, 0 means the first address, and then 1 means the second address, and 2 means the third address, right? But in this case, the actual address goes over here, okay? But that was close also. Does the stack know how long Joe is? And yes, right? So we'll write some code to prove that, okay? So we come back over here and we'll still use this one. I'll remove this. Let me give myself some more space here. Okay. Include string. Also, let me start doing this. Okay. And then using string, right? So now, like, if we do it this way, right? So then we're helping future programmers. Like, oh, I'm using cout from IOStream. I'm using a string from this using. I can't type. What's wrong with me? And I'm using string from the string header, okay? And if we had more objects here for IOStream, we would put them here, and that way, like, someone in the future, maybe ourselves, right? We're like, oh, okay, so I'm using this object from this header. I'm using this object from this header. Okay, it's all about organization, right? So if you organize your code, you can be doing yourself a favor in the long run. Include string using string, meaning now I can, well, actually what I want to do is I want to say letter first. So I want to create one letter. Notice single quotes, okay? Single quotes right there, single quotes, not double quotes. Character type. And we can validate that by hovering over letter, and we can see letter is a char or a character type, okay? Yeah, it's the address of the array, but I don't want to get into many details about that. When we get to arrays, we'll study memory and arrays and that, okay? Usually in any programming language, you can type the name of the variable and then a dot, and it'll tell you if there's extra functionality. There's no extra functionality for a character type. So this is a fundamental type or a simple type in C++, so it's just a character. It's represented by 1 byte in memory, and that's it. So it's not like the string, meaning we can't say, we'll use Joe, and if we say name dot, notice there's a lot of functions for string. So far we've used size. We want to know the size of the string, and what we will do right now is we'll ask the string some questions, and then we'll display them to screen so that we can answer some memory questions for string. One of them will be like, does the stack know how long Joe is? Okay. And of course the answer is yes, but we're going to show you how, okay? First of all, we can memory of string on the stack is, let me see, memory of string on stack is, and then we go ahead and run this program. Examples for run in terminal. So FEF4, okay. What else do we want to ask? We maybe want to ask maybe not region, memory space used by string is, and then we can use the special functions size of, and then name as a function parameter. Let's have some new line characters here. Okay, so memory space used by string is, so recall I said that the string is a class, and if you were introduced to classes in Python, then you know that a class is a group of variables and functions encapsulated in a class, okay? So if there's variables in a class, then the compiler needs to know about those variables, and then it can allocate enough memory for all those variables in that class. So that's what we're asking it here, like how many bytes of memory is this name, which is a string using. And we run it. And it's 24, so it's using 24 bytes. So if we come back and look at this, so then it would use memory from 100 all the way to 76, right? So that's 24 bytes. And all those are for character, well, actually not from 100, from here, from 95, right? 95 minus 24, 71, all the way to 71. And that region would be allocated to the string, meaning we would need to show that main has more memory allocated, okay? Question here? And if that's kind of like hazy, what we can do is we can say, okay, how much memory does letter take? And we can run it. I didn't put the new line. Cancel. Right here. Okay, let's run it. You may be asking, well, why do I need to know this? We are going to get into dynamic memory in the future. Like, you will have to create dynamic memory. So that's why it's always good to at least have an idea of how objects are working, and that way when you start writing code, you'll be like, oh, so that's how they were doing it. So notice memory used by char 1, and that is the case because 8 bits represent 255 a number up to 255. Okay, so with 8 bits of memory, you can represent the number 0 all the way to 255, and by turning on and off zeros and ones. Okay, questions here? So this is 1 byte, this is 24 bytes. Why is this one larger? Because it's a class and it has variables encapsulated in code, and if there's variables in there, then we know that it needs space for those variables. Okay, so what else can we ask from string? Well, we know the easy one, size of name string is, we can just say name.size. So that's what? 1, 2, 3. And if we want to index, then it's 0, 1, 2. So if we want to access O, we say name subscript operator or open bracket, close bracket 1. It'll access this one, okay? And if we want to access this one, it's 2. So size and index are always off by 1. So I think I showed you with the example in the for loop, right? That we always have to mind that. But if we use a for range, then we don't have to worry about indexes or anything like that. It makes it easy for us. Okay, so size of string, let's see what happens here. Run. Three. And that, I mean, we should have known that, right? So if we look at this, JOE, and then we have a question, does the stack know how long name is? Right, so the stack knows this is 3, but then how long is the string? Does it know? Like, well, yes, it knows. How does it know? With size. But also, does the string, or how many characters are allocated to the string when we create a variable? When we say string name equals Joe, does C++ give us only 3 address spaces, or does it give us a block of address spaces? And why is that important? So when you create a string and then you want to copy a string to another string, or let me backtrack. If you create Joe and then you want to append Joe's last name, like maybe it's long last name like Rodriguez, then did C++ allocate enough characters blocks or 1 byte blocks for Rodriguez? And if it doesn't, what does it do? Okay, so first, before we answer that question, what I will do is I'll say, okay, capacity of name string is the capacity. Notice, like, I'm just calling functions, so programmers wrote code for us that we can take advantage of. Here we're just trying to understand how a string works in memory. Okay, run in terminal. So capacity of string is 15. So meaning they gave us from 87 to maybe like 72, assuming this were 15 slots, right? So we can add how many? 12 more characters to Joe. Is it? Yeah, 12 more characters before we run out of memory for string. So if we have been granted memory slots 87 through 72, we can use 12 more slots before we run out of memory for string. And then the algorithm that manages the heap has to go look for, say we need 20 address slots. Then the algorithm that manages the heap has to go find for 20 free 1 byte addresses, 20 bytes free, and then allocates those, gets this memory values and puts them into the new region, and then deletes this memory because, well, we're not going to be using this memory anymore. Say it was like Joe Saldivar Rodriguez or something like that, some long last name, right? Combo. So then we know it's not going to fit. So then the algorithm behind the scenes would grant us more memory, move the values to the new memory, delete this memory to prevent a memory leak, and then all this seamless for us, right? Like, but that's what capacity means. Like, we can use up to 15 characters. Questions here? What else can we ask it? So we asked memory location for the variable, the size for questions? So we can generate, so the question is, can we append to the string indefinitely? And the answer is no. Remember, this is 2 to 4 gigabytes, so that'll be like a lot of characters, but eventually we will run out of space. Is this from chapter 6? The book doesn't really talk about strings, so this is the source, like I'm the source for this. But if you need validation, I got this information from the CPP reference website. CPP reference, right? So, and from Bjorn Strostrup's books, right? So he has advanced books, right, where he talks about this stuff. So what I try to do is I try to explain this to students, because I think Gaddis talks about like dynamic memory, but he doesn't really give you the whole picture. And I always feel that if you see the whole picture, then hopefully that helps you understand the overall, right? And it helps you understand better. So will this be on exams or on quizzes? Yeah, because I mean I'm covering it, and you can always refer to this in the lecture videos, okay? cppreference.com, you can just do a search for like how strings work. Okay, where was I? Oh yeah, the question was append to the string indefinitely, or is there a limit to the size? So yeah, there's a limit to the size of a string, and that is like, well, how much memory do we have available, right? So that's how big a string we can create. And if we go back to some code here, if we look at size, notice it has this size of t variable. So then we're like, oh, what is size of t? What is this guy? It's an unsigned integer, so meaning it only supports positive values. So that would be like 4 billion, I think, in the 4 billions, because integer goes to like 2.1 billion. So if we double it, right, so 4.2 billion characters. But you probably won't get all those because the program has to load and we got other stuff going on, right? But it'll be, I don't think you'll ever need to create that long a string. And if you want to try it, you can just create a loop that just indefinitely loops, and you just append to the string with string dot pushback, and you just see how long it takes to crash. The computer won't crash, the program will crash. Okay, what else did I want to ask? It's I think there was something else. Let me see here. I'll look at this code. I thought I had something else on the Thursday class. Let me double check. Examples. Oh, that's it. That's it. Okay, I just wanted to double check. Okay, so there's no questions. Okay, so yeah, I answered that. So at least this should help us understand how strings are loaded onto memory. Always on the left side, you have a reference. Actually, the way they've written code, it'll be a pointer, but the pointer and reference are almost the same. They're cousins. So we'll talk about pointers in the future, and that's how they create dynamic memory, and then that's how this is being referenced, okay, on the heap. Okay, so if we have Joe from Python, and most programming languages support this, you can reference a character, and that will display J for us. And if we put 1, that'll be O, and then 2E. And we don't want to go beyond the scope of what's available to us, and that's only JOE, because we will get strange errors, and we don't want that, right? So if you are using subscripts, then you need to make sure to understand the size of the string, right? So I think that's where most languages now use the for range, right, to avoid off by 1 errors or accessing beyond the available memory. So even though we know that we have all this memory available up to 72, right now this one is on reserve. It's not available for us to subscript, meaning to say like, well, I want to know what's at 3. Well, because there's nothing at 3. This is just memory that's available to the string in case we append more to it, okay? Okay, so this is how you create and assign value to a string. But you can also say string name 1 hello. So notice we use this special parameter, and when we talk about classes, we'll understand how that works. And we can also say string name2. I won't cover all the different ways you can create a string, okay? Pretty sure we can do this. H I, and then, well, just to validate that, and we say okay, so show me the value of name1, a new line, and show me the value of 2, and let's do new line here, and we execute this piece. Notice down here, hello and hi, right? So this one's, what's this right here? This is known as an initializer list, so we can use those. Notice these are single quotes here, they're characters, and then C++ understands that and it creates the variable for us, okay? Okay, questions here? I mean, this is elementary for creating strings, right? And this is as complicated as it'll get for us. We can also, I know for the exam, there's some string questions. So if we have hello and we want to add to it, we can say name1 dot pushback, meaning add something at the end. So is it, well, I guess it'll let me know. I don't usually use this okay character, except the character, and then I say hello. I wonder, let me see if it'll accept this string. No, it has to be characters, okay. So hello, I'll just put a T because I don't want to type everything. Okay, so that should add a space and a T, and we can see it in the output. So let's go ahead and run. So notice right here, it added space and T to the string, and assuming it was Joe and we added a space and T, then this would be the space and this would be the T, okay? And then we would still have some more free spaces before memory had to be reacquired to accommodate our capacity. And we can also append to a string. So I think if I change this one, name1.append, and I say hello there, then this should also work. So now I should see hello space there. And again, someone wrote code for us, right? So we don't have to write this. We can just call those functions. So notice right here, hello space there. And questions? Okay, there are more functions, like you can replace, but I don't think I want to get into that. Because the assignments I grant for, or I give for string are usually, if you know how this works, always at the end. Notice if I do pushback and I'm like, well, really, is it at the end? So let me put an A. So then we should see hello there A. So notice right here, when you use pushback, it'll always be added to the end of the sequence, So let me just change this to Joe, and then Joe, we'll say Joe Doe, and we run it. So we have Joe Doe, and if we were able to put it in memory, this would be the space, there would be a DOE, and then we would still have 8 more characters to play with before we run out of space for this string. Okay, only for the string, not for our program. So questions here? Okay, this is what I'm going to do. I'm going to stop the video here.